Dear students, in our last class, the topic that we discussed was a combination of the capacitor. An important topic, just very quickly we will revise because we will be using all these equations in our next topic. So, the first, series combination of the capacitor. When number of capacitors are connected in series, the effective capacity is given by 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3 and so on up till 1 by Cn, where Cn is the capacity of nth capacitor. For 2 capacitor, we can write straight away and the modified version of the previous equation. Cs is equal to C1 C2 by C1 plus C2. For n identical capacitors, Cs is equal to C by n. And the energy stored in the entire combination Us is equal to half Cs V square. So, these are the equations related to the series combination. In parallel combination, the effective capacity will be always given by Cp is equal to C1 plus C2 plus C3 and so on up till Cn. And for 2 capacitors, Cp is equal to C1 plus C2. For n identical capacitor, Cp is equal to n into C, and the energy stored in the combination Up is equal to half Cpv square. So, let us use this in the next problem, question from March 2016. So, the statement goes like this: energy stored in a system consisting of 2 capacitors in series and connected across a 4 kilovolt line. So, the value V is given, it is a 4 kilovolt it is given. So, we have to write 4 into 10 to the power 3 volt. Okay. And it is initially connected in series, and the energy stored is given, Us is given, which is 8 joule. Okay. When the same 2 capacitors are in parallel across the same line, energy stored is 36 joule. So, when they are connected in parallel, the total energy is 36 joule. Find the capacitance of the capacitor. So, we have to find the value of C1 and we have to find the value of C2. So, I am going to start with this equation, which is a Up. Energy stored in the parallel combination is equal to half Cp V square. So, Up is equal to, so we will substitute that, the value of Up is 36, that is equal to half, and the value of Cp is C1 plus C2. The value of V is here, square of it will give you 16 into 10 to the power 6. So, here we have 2 8 times, then we have 36 by 8 is equal to, or we will bring this to the left, that becomes 10 to the power 6, and then when taken to the numerator it becomes 10 to the power minus 6, that is equal to C1 plus C2. Now, we can further simplify this. Here we have 8 4s are 32 point, then we get 4 here, 4, 40 means 8 5, so it is a 4.5 into 10 to the power minus 6. Now, that is the value of C1 plus C2. So, now we know the sum of the capacity. So, we will use one more equation for series combination. Us is equal to half Cs V square. The value of Us is 8. That is equal to half. The value of Cs is C1 into C2 by C1 plus C2 into the value of V square of it, which is 16 here, into 10 to the power 6. Now, 8 2s are 16 here, correct? So, this will get cancelled, right? Now, C1 into C2, let me write that, that is 1 is equal to C1 into C2 by C1 plus C2 is this, here it is, C1 plus C2 is 4.5. 4.5 into 10 to the power minus 6, okay, minus 6 into 16 has cancelled. Now, this 10 to the power 6 is there. Now, what we get here is C1 into C2 is equal to 4.5. This will not get cancelled, this becomes 10 to the power minus 12. So, C1 into C2 is 4.5 into 10 to the power minus 12. So, basically we have found the sum of the capacity and then we have found the product of the capacity. So, we have to find the individual now. To find the individual, I will make use of C1 minus C2 the whole square is equal to C1 plus C2 the whole square minus 4C1 C2. Now that is of the format A minus B the whole square is equal A plus B the whole square minus 4AB. C1 plus C2 is here 4.5. 4.5 into 10 to the power minus 6 the whole square minus 4 into C1 into C2 is here, 4.5. 4.5 into 10 to the power minus 12. Now this 4.5 square, 4.5 square is 20.25 into 10 to the power minus 12 minus here 4.5 4 times, that is 18 into 10 to the power minus 12. Now 20.25 minus 18 is nothing but 2.25 into 10 to the power minus 12, but that is C1 minus C2 the whole square. So what is C1 minus C2? Square root of it. So square root of 2.25 is nothing but 1.5 into 10 to the power minus 6. So we got the difference now. So now we know the sum, we know the difference, so therefore you can add this. So let this be 1, let this be 2, let this be 3. So I will add a question. So let me write that here. So I will add equation 1 and 3. Okay, equation 1 and 3. So when we add on the left hand side now, so C1 plus C2, C1 minus C2. When you do this here, okay, let me write. So C1 plus C2 is 4.5 into 10 to the power minus 6, and C1 minus C2 is 1.5 into 10 to the power minus 6. So when you add, this will get cancelled, get 2C1 is equal to 4, 5 and then the 6 into 10 to the power minus 6, because 10 to the power minus 6 is common. Therefore the value of C1 is 3 into 10 to the power minus 6 farad, or 3 microfarad is the answer. So once you get the value of C1, you substitute in any one of the equation, either in 1 or in 2. Okay. So I will substitute in 1. So in 1, C1 is there, which is 3 micro, 3 into 10 to the power minus 6, plus C2 is equal to 4.5 into 10 to the power minus 6. Okay. So what is the value of C2? C2 is 4.5 minus 3 is 1.5 into 10 to the power minus 6 farad, which is 1.5 microfarad. So that is the value of C2. So a question again from the examination. So hope you have understood the entire explanation given to that particular numerical. So where we use the equations related to series as well as the parallel combination. So this entire topic is important from all the exam point of view. Okay. So next we will learn one concept related to the combination only, then we will solve the problems, and this is the last class of this particular chapter. So there will begin a test in this particular chapter soon, so that is why I start revising. In the last test, some of you have written the test by referring the notes directly, and then you have forwarded the paper. If that is the case, better don't write the test. So next time if you do that, I will tell you who are those students. Don't write the test, if you are copying and then you are sending the paper. Okay. Okay, so the topic, what is the topic here? Combination of two capacitors in parallel, in that at least one must be charged. So let us consider this particular situation where we have a capacitor. This is the capacitor. Okay, it's a charged. So C1 is the capacity and Q1 is the charge on it. V1 is the potential difference, and then U1 is the energy stored in it, okay, because it's already charged. Because this topic is applicable only when at least one of the capacitor must be charged. Now again there is one more capacitor, so that can be either charged or uncharged, because since I have taken this as a charge, the second one is optional. So any one must be charged, any one. If both are charged, it's fine, but at least out of the two, the other also. And again here I am going to assume that even the second is also charged. It can be charged or uncharged. So C1, then Q1, and then C2, Q2, V2, and then U2. Now these two capacitors are connected in parallel like this. They are connected in parallel. So this is before they are connected in parallel. This is before, this is after. Okay. So this is before they are connected. This is after they are connected in parallel. Once they are connected in parallel, their capacity will remain the same, C1 only. C1 and C2. Capacity will not change. But since they are connected in parallel and in parallel combination, potential difference is same. So that's why potential difference across these two becomes V. So it was V1 and V2, now it becomes V. Now how it becomes V? Moment they are connected in parallel, the charges will flow from one capacitor to the other capacitor. So that the new charge will be Q1 and Q2. Look at the symbol used. So here small q1, small q2 are the charges before they are connected in parallel. Capital Q1 and capital Q2 are the charges after they are connected in parallel. What about the energy stored? The energy stored is U1. What is the energy stored here? The energy stored is U2. But U1, U2 are the symbol already used. So therefore, let's take U1 dash and U2 dash are the energy stored. Hope you understood the symbol use. This is before and then this is after. So I'm going to write here the differences in the two cases. So this is before they are connected in parallel. This is after they are connected in parallel. So I'm going to start with the capacity. Their capacity will remain C1 and C2. Here also it will remain C1 and C2. Okay. Then the next is a potential difference. Potential difference is a V1 and a V2. Now here it becomes a V. Same, this is called common potential because they will attain same potential when they are in parallel, because we know that in parallel combination potential difference is same. And the formula for that potential difference is given by C1 V1 plus C2 V2 by C1 plus C2. So this is using the parallel combination of the capacitor, we get it. Okay. So what is the common potential? V is equal to C1 V1 plus C2 V2 by C1 plus C2. So what is the charge? The charge before is a Q1 and Q2. What is the charge after? The charge after is Q1 and Q2, which we can calculate. Q1 is equal to C1V and Q2 is equal to C2V. Here also we can find Q1 and Q2 before. It's a C1V1 plus C2V2. C1V1, C2V2. Here C1V, C2V, because V is same. Clear? How about the energy stored? Energy. U1 is equal to half C1V1 square. U2 is equal to half C2V2 square. Okay. U1 is equal to half C1V1 square. U2 is equal to half C2V2 square. How about U1 dash here? Half C1V square. U2 dash is equal to half C2V square. C1 V1 square, half C1 V1 square, half C2 V2 square. Here half C1 V square, half C2 V square. Clear? Then the total energy before and total energy after will not remain same, because during the sharing of the charges part of the energy is lost in the form of heat. So therefore, the loss of energy is given by delta U. That is loss. This is the formula for loss of energy. Okay. That is equal to energy before. Energy before is half. Okay, let me write like this: U1 plus U2. Okay, that is this U1 plus U2. This is the energy before minus energy after, which is U1 dash plus U2 dash. So this is how we find the loss of energy due to the sharing of charges. So this is a completely different set of equation and can be used only under this condition. What is the condition? Combination of two capacitors connected in parallel, and when they are connected in parallel, at least one of the capacitor must be charged. If both are uncharged, then all these equations are of no use. If both are uncharged, okay, if both are charged, then it's fine, but out of the two, at least one must be charged. This is called common potential, which is attained after they are connected in parallel. So these are all the formulas to be used after they are connected in parallel. These are the formulas to be used before they are connected in parallel. So hope you have understood this. So let's solve a problem based on the equation which I have explained just now. See the statement of the question related to the topic that I have explained just now. So let's start. A 600 picofarad capacitor. So therefore there is a capacitor C1 600 picofarad is charged by 200 volt. So V1 is a 200 volt. Calculate the electrostatic energy stored in it. Okay, so we have to find U1, half C1 V1 square, half C1 is 600, pico is 10 to the power minus 12 into V1 square, 200 square of it. So we can simplify like this. This is here 300 in 10 to the power minus 12 into 200 can be written as 2 into 10 to the power 2. Square of it becomes a 4 into 10 to the power 4. Now here we have 4 3s are 12 into then the power 4, and again here 2 is there, 6 and this 10 to the power minus becomes 10 to the power minus 6. So therefore so much joule. So this is the value of U1. Okay, what is they have asked? The electrostatic energy stored in it, right? It is then disconnected from the supply and is connected in parallel to another uncharged capacitor. So C2 is again 600 picofarad, another one uncharged. So V2 is 0. So when C2 is 0, sorry, when V2 is 0, what is the value of U2? U2 is a half C2 V2 square, which is 0. Why? Because the value of V2 is 0. So this is the energy stored in the second. Okay, so the supply and is connected in parallel to another uncharged capacitor. So options are, what is the energy stored in the combination? Yeah. So energy stored in the combination means after they are connected in parallel. So we have to find the total energy after they are connected in parallel. So before that, we have to find the value of V, which is common potential, which is C1 V1 plus C2 V2 by C1 plus C2. What is C1? 600 pico 10 to the power minus 12. Into the value V1 is 200 plus V2 is 0, right, divided by C1 plus C2, 600 plus 600, 1200 common into 10 to the power minus 12. Okay, so that is equal to, this will get cancelled here, this 600 here, this is twice 200 by 2 is nothing but 100 volt. So this is the common potential now. So let us find what is the energy stored in the combination. Energy stored in the combination is nothing but after they are connected in parallel, okay, which is nothing but U1 dash plus U2 dash, okay, U1 dash plus U2. What is U1 dash plus U2 dash? It's half C1 V square plus half C2 V square, correct? After they are connected in parallel. Whatever that we calculated here, it was before they are connected in parallel, right? This is after, potentially same, right? So half is common, C1 plus C2 into V square, okay, right? Half into C1 plus C2, 600, 600, that's 1200 pico, 10 to the power minus 12, okay? And then the common potential V is here, which is 100. 100 is 10 to the power 2, square of it is 10 to the power 4. Now that's equal to here 12 by 2, that's a 6. 6 into then 4 plus 2, 6, 6 and then 10 to the power minus 12 is minus 6, 10 to the power minus 6 joule. So this is U1 dash plus U2 dash, okay? U1 dash plus U2 dash. And this is what they have asked, you know, what is the energy stored in the combination? This is the energy stored in the combination. That means after they are connected in parallel. Okay, so we have another option which is calculate the loss of energy. So how do you find the loss of energy? Loss of energy formula, delta U is equal to, it's U1 plus U2 minus U1 dash, correct, plus U2 dash. So U1 is here, 12 in 10 to the power minus 6, U2 is 0. So it will be 12 in 10 to the power minus 6 only, correct? Minus, what is U1 dash plus U2 dash? It's here, 6 into 10 to the power minus 6, 6 into 10 to the power minus 6. So therefore the difference comes as 6 into 10 to the power minus 6 joule. Okay. So hope again the problem is clear. So to find the loss of energy, we need to find U1, which is here, we need to find U2 and then U1 dash plus U2 dash. This is nothing but that first option. What is the energy stored in the combination? Combination means together after they are connected in parallel. I hope you all have understood. So let's try one more numerical from the examination. So this is the last numerical of this particular chapter. Go through the statement. A 4 microfarad capacitor is charged by a 200 volt. So first capacitor C1, 4 microfarad charged to 200 volt supply. It is then disconnected from the supply and is connected to another uncharged. So there is another 2 microfarad, another uncharged. Uncharged means V2 is 0 capacitor. Okay, in parallel. How much electrostatic energy of the first capacitor is lost? So we have to calculate the energy stored lost by the first capacitor. Okay. So first we'll calculate what is the energy stored in the first, which is half C1 V1 square. That is half. What is C1? C1 is 4 micro. 4 into 10 to the power minus 6 into V1 is a 200 square, which is a 4 into 10 to the power 4, right? 200 square is 4 in 10 to the power 4. Okay, so this is 4, 16 by 2 is nothing but 8 into 10 to the power minus 6 and plus 4 is minus 2 joule. So that is the value of U1. Now we have to find the energy lost only by the first. So that's why now let's first find the common potential. Only then we can find the energy stored in each capacitor after they are connected in parallel. So what is the formula for common potential? C1 V1 plus C2 V2 by C1 plus C2. What is C1? 4 micro, 4 into 10 to the power minus 6 into, what's a V1? 200 plus C2 V2, so this is 0, V2 is 0, divided by C1 plus C2, 4 plus 2, 6, 6 into 10 to the power minus 6, correct? 4 plus 2 is C1 plus C2, right? Now, here we have this power will get cancelled, we get 4 into 2, 8. It's 800 divided by 6. So, the value 800 divided by 6, 800 divided by 6, you will get 133.3 volt. Now, that is the common potential. Now, let us find the energy stored in the first capacitor after they are connected in parallel, which is U1 dash half C1 V square, half C1 is 4 micro, 4 into 10 to the power minus 6 into the value V is 133.3 the whole square. So, 133.3 the whole square, then into 2 to the power minus 6. So, that comes equal to 3.553 into 10 to the power minus 2 joule, that is U1 dash. So, this is the energy stored in the second, after they are connected in parallel, energy stored in the first capacitor after they are connected in parallel. So, we need to find how much energy is lost only by the first capacitor. So, that is why the loss of energy here, we do not use that loss of energy formula, that is the total energy loss in the entire combination. Here we want to find the energy stored lost only in the first capacitor. So, that is why it is U1 minus U1 dash. So, what is the value of U1? U1 is 8 into 10 to the power minus 2 minus this one 553 into 10 to the power minus 2. So, 8 minus 3.553. So, the difference is a 4.447 into 10 to the power minus 2 joule is the answer. So, that is U1 minus U1 dash. So, energy lost in the first capacitor, right. So, hope you have understood all the numericals that we have solved related to this new topic, and that ends this particular chapter, and soon we are going to have the test, and before that we will have an interactive session to clarify your doubts. So, start reading, because there are a lot of derivations are there. Some of the derivations are difficult, a lot of numericals are there, but definitely an important chapter from the exam point of view. So, I am going to continue with the new chapter in my next class.